continue our use of limits, we want to determine the continuity, or whether a function is continuous at a point. We have three requirements. For a function f to be continuous at the point x equal to c, f of c must be defined. We must have a y value there. The limit f of x must exist as x gets closer and closer to c. And finally, these two answers have to be equal to each other. An unofficial way to look at continuity is if you're able to draw the graph of the function without lifting your pencil near x equals c. Let's discuss the continuity for f of x equal to x minus 2 divided by x squared minus 4. The first thing we're looking for is the domain, or what values of x are going to cause problems. A nice approach to this is to factor the denominator here so that we can see what happens. Notice both values in the denominator, both x equal to 2 is going to cause a problem, and x equal to negative 2 is going to cause a problem, because these give us a 0 in the denominator. However, since these two values, x minus 2 binomial, are both the same and they cancel out, we have what's called a removable discontinuity at the value of x equal to 2. Now, x equal negative 2 will give us a vertical asymptote. So once again, that will cause a problem for us. Let's see if we can draw a graph of this now. Just finding a couple quick values of f of x. If we take x equal to, say, 0, negative 1, and 1, going back to our original equation, if we put 0 in here, we wind up with negative 2 over negative 4, so that gives us 1/2. If we put negative 1 in here, we get negative 3 over negative 3, which is 1. And if we put a value of 1 in here, we wind up with negative 1 over negative 3, or 1/3. So our graph comes down like this, and we have to be careful because notice we have a removable discontinuity at x equal 2, so we therefore have a hole in the graph. So our graph looks like this. If we go from the other side of negative 2, of the vertical asymptote, we have something that looks like this. So in conclusion, our graph is continuous everywhere except x equal 2. It is not continuous. And at x equal negative 2, it is not continuous.